All right, guys, let's go with our final part of Chapter 8, Section 4, which is adding and subtracting radicals. And we're going to talk today about doing this with fractions. So if you take a look at this problem here, 2 times the square root of 32 over 36 plus 2 times the square root of 27 over the square root of 108. So again, don't just write down, we can't do it. We're giving you these problems because they can be done. So this is the book's methodology. I will show you a different approach on the link that I'll put up with more examples. So they're going to take out, so it'll be 2 times the square root of 16 times 2 over the square root of 36. Plus 2 times the square root of 9 times 3 over the square root of 36 times 3. So basically what they're doing, you're looking for perfect squares that go into any of the radicals. So that would become 2 times 4 times the square root of 2 over 6 plus 2 times 3 times the square root of 3 over 6 square root of 3. And then basically what you're looking to do is cancel as much as possible. So what would happen here before, and I probably should have done this beforehand with the canceling, but this would cancel right here and become a 2, and this is going to cancel and become a 3. This is going to cancel and become a 1, and this is going to cancel and become a 2. So now these also cancel here. So this is 2 times 1/2. Well, 2 times 1/2 is 1. So you would end up with a finished product here of 4 square root of 2 over 3. You could leave it as this also. This would be acceptable. 4 square root of 2 over 3 plus 1. Now, sometimes people want it with this format. So both of these answers would be correct. You would turn 1 into 3/3, and now because you have the common denominator of 3, you can put this all over one line like you see here. I would prefer to leave it in this format here. I think it's cleaner, and I think it's simpler, but to each their own. Okay, here we have the square root of 80 over of y to the 4th plus the square root of 81 over y to the 10th. So again, we're going to break this up. So this is going to be the square root of 16 times 5, right? 16 goes into 85 times, so over the square root of 4, y to the 4th, excuse me, and then plus the square root of 81 over the square root of y to the 10th. So what we're going to end up with here is 4 square root of 5 over y squared plus 9 over y to the 5th. Now we can't stop here. Okay, we're going to find a common denominator between the two of these, and that's going to be y to the 5th. So you multiply both the numerator and the denominator right here. So what they did to get to this step is they did y cubed over y cubed times 4 square root of 5 over y squared, all right, and then add this onto the end, right? So that gives us this, right? 4y cubed, square root of 5, y cubed times y squared equals y to the 5th. Now we have common denominators here and here. So now you can write this as one fraction as 4y cubed square root of 5 plus 9 over y to the 5th. So this pretty much are the last two examples I'm going to do for you on this. Actually, the only two I'm going to do on this PowerPoint. Check the link also with the additional examples. Hey, we're done with this section. Guess what? Quiz time's coming. Have a good day. Do the assignment. Practice the problems. You got plenty of time. Talk to you soon.
Bye.